What is a star that has twice the mass of the sun, has a temperature of billions of degrees, and is the size of a small city? The answer: a neutron star. These tiny objects are some of the most extreme in the universe, containing insane gravity, very strong magnetic fields, and more. Before we get into that, however, I would appreciate if you would like the video, subscribe to the channel, and hit the notification bell so you stay tuned for future content. Also, I'm recording at a different angle because otherwise the window screws everything up, and we do not want that. Okay, so how does a neutron star come into existence? The answer is simple. It's the remnant core of a dead star. Yeah, I seem to talk about stardust quite a bit on my channel. Anyway, these aren't ordinary stars. These are stars that contain dozens of solar masses when they were alive. They were big enough to explode in a supernova, but they weren't quite big enough to become black holes. What happened was that when the star collapsed, it pushed down on its core, and to put it lightly, the atoms in the core tried to fight back. A black hole forms when the effects of these particles are futile, and gravity emerges victorious. However, when it comes to less massive stars, there isn't quite enough material to crush the core into a singularity. In other words, the particles win. However, this victory comes with quite a heavy cost. The particles are pushed into the tiniest spaces possible, causing the resulting object to be only a few miles wide, but still a mass of 2 suns. This is what we call a neutron star. As you can guess, neutron stars are incredibly dense. One car of this material can weigh hundreds of trillions of tons. This density causes the neutron stars to have extremely weird properties. For one, the gravity is intense. Light can escape a neutron star pole, but not much else can. Another thing that can happen is extremely tiny amounts of this material can pile into mountains millimeters high, but is still able to contain more mass than entire mountain ranges on Earth. Well, it gets crazier. It is theorized that deep in the core of a neutron star, where things are even more dense and extreme as they couldn't get crazy enough, protons and neutrons melt down completely, creating some sort of quark soup. For reference, normally a proton or neutron contains 3 quarks, and these quarks would be attached together by particles called gluons. And these quarks are normally inseparable. If you try to pull them apart with a lot of energy, they generate 2 more quarks, which I feel should violate the laws of physics. After all, is matter unable to be created or destroyed? I don't know. Anyway, under the extreme conditions in a neutron star's core, these gluons would melt away, and the quarks would exist independently of one another. Last but not least, a neutron star's magnetic field is crazy. Neutron stars rotate at hundreds of times per second, largely due to their small size and high mass. This energy creates a magnetic field that is so intense that, if a neutron star was placed 100,000 miles away from Earth, all of our credit card info would be wiped, and eventually we'd be cooked due to the star's extreme temperature. But that's besides the point. And that wraps it up for this video about neutron stars. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.